Chapter 10, Exponents and Powers. Mass of the earth is 5.597000, number of zeros, kg. We have already learnt in earlier class how to write such large numbers more conveniently using exponents. That is 5.97 into 10 raised to 24 kg. We read this symbol as 10 raised to power 24. 2 raised to 5 is 2 into 2 into 2, 5 times. 2 raised to m is 2 multiplies itself m times. Let us now find what 2 raised to minus 2 is equal to. Powers with negative exponents. Ten raised to 2 is written as 10 into 2, that is 100. 10 raised to 1 means 10 will multiply itself only once, that is 10 only. So we write this as 100 upon 10. Now what is 10 raised to 0? 10 raised to 0 is 1, that is 10 divided by 10. Now what is 10 raised to minus 1? That is 1 upon 10. 10 raised to minus 2 is 1 upon 10 into 1 upon 10. That is 1 upon 100, which can be written as 1 upon 10 square. So 10 raised to minus 2. If the exponent is negative, that term will be written in denominator with positive power. This is 1 upon 10 square. 10 raised to minus 3 is 1 upon 10 cube. So what is 10 raised to minus 10? It is 1 upon 10 raised to 10. Now similarly we can prove this, or we can find out powers of 3. Power 3 raised to 0 is 1, and if the power becomes negative, we write this as 3 raised to minus 1 is 1 upon 3, 3 raised to minus 2 is 1 upon 3 square, and so on. You can now find the values of 2 raised to minus 2 in similar manner. 2 raised to minus 2 is 1 upon 2 raised to 2. In general, we can say that for any non-zero integer a, a raised to a negative power can be written as 1 upon a raised to positive m, where m is positive integer minus m is multiplicative inverse of a raised to m. Find the multiplicative inverse of each of the following. 2 raised to minus 4. Multiplicative inverse of this is 2 raised to plus 4. Multiplicative of 10 raised to minus 5 is 10 raised to plus 5. Multiplicative inverse of 7 raised to minus 2 is 7 raised to 2. Multiplicative inverse of 5 raised to minus 3 is 5 raised to 3. Multiplicative inverse of 10 raised to minus 100 is 10 raised to 100. We learned how to write numbers like 1425 in expanded form. Yes, this is in thousands place, so we write this as 1 into 10 cube. This is in hundreds place, so we write this as 4 into 10 square. 2 is in tens place, so 2, this can be written as 2 into 10 raised to 1, and 5 is at units place, so that is 5 into 10 raised to 0. Now observe that the power of 10 goes on decreasing. So now if we want to write down 1425.36, 1425 divided 0.36, then this part is same. For this 3 we write this as 3 into 10 here 3 into 10 raised to minus 1. The power will go on decreasing. Plus 6 into 10 raised to minus 2, which in fraction form this one is 3 into 1 upon 10, and that can be written as 3 upon 10, and this one is 6 into 1 upon 10 square, so that is 6 upon 100. So we can write the number with a decimal point in expanded form. Let us try to write this 1. This is in thousand place, so it is 10 cube plus 0 into 10 raised to 2 plus 2 into 10 raised to 1 plus 5 into 10 raised to 0 plus 6 into 10 raised to minus 1 plus 3 into 10 raised to minus 2. Similarly, you can complete this one. Laws of exponent. These are laws of exponent. When the bases of two numbers are same, a is the base and this m is called as power or exponent. Similarly, a is base and n is power or exponent. If the bases are same and we divide those numbers, then that simplification is same as a raised to difference of these powers. A raised to m, that whole raised to n, is equal to a raised to m into n. A raised to m into b raised to m. Now the bases are different, but the powers are same. That can be written as a into b raised to m, that is their product raised to m. A raised to m divided by b raised to m. Again, the bases are different, power is same. We can combine this fraction as a upon b whole raised to m. A raised to 0 is equal to 1. Find the value of 2 raised to minus 3 is 1 upon 2 raised to 3. So this is 1 upon 2 into 2 into 2, that is 1 upon 8. This is 1 upon 3 square, that is, now the number is in denominator with negative power, so bring it in numerator. Here we can explain this by using 3 raised to 0 is equal to 1, and now by using a raised to m upon a raised to n is equal to a raised to m minus n. So this one is 3 raised to 0 minus minus 2. Minus of minus becomes plus, so this is 3 raised to 0 plus 2, which is equal to 2. Now here the bases are same, so and multiplication of the number, so we can add the powers. Here there is difference, so subtraction of powers as bases are same. Express 4 raised to minus 3 as a power with base 2. 4 raised to minus 3 is 1 upon 4 raised to 3. This can be written as, this 4 can be written as 2 square raised to 3. Now by using a raised to m raised to n, we have a raised to m into n. So this is 1 upon 2 raised to 6. That can be also written as 2 raised to minus 6. Simplify and write the answer in exponential form. This one is 2 raised to 5 minus a division, and bases are same, so difference of powers raised to 5 into 2 raised to minus 5. This is 2 raised to minus 3 raised to 5 into 2 raised to minus 5. A raised to m raised to n is equal to a raised to m into n, so this becomes minus 15 into 2 raised to minus 5. Bases are same, product of numbers, so addition of their powers, which is actually 2 raised to minus 15 minus 5. So answer is 2 raised to minus 20, which can be written as 1 upon 2 raised to 20. Minus 3 raised to m plus 1 into minus 3 raised to 5. Bases are same, product of numbers, so addition of their powers, and this is equal to minus 3 raised to 7. Bases are same, so we equate the powers because the terms are equal. Therefore what we have, m plus 6 is equal to 7. Transposing 6, we get this as 7 minus 6, so value of m is 1. So by using these laws of exponents or powers, we can solve exercise 10.1.